So we've got one boat, boat A, going down due south, and another boat, boat B, going due north. And we want to find how fast is the distance between them changing. So that's point boat A and boat B, and we know at the very beginning they are 100 apart. 100, I don't know what we're measuring it in this time, for 100 kilometers. So good, we're in metric. So the question is, how far are they apart? So we're trying to figure out how fast is that distance changing. So let's assign some variables, and it's this distance is changing, and so is this. Now it seems like a little bit of an awkward diagram to find a relationship, but I'm going to make it a more obvious right-angled triangle. There we go. And now we've got a triangle right here. And we can say that this is y, and we know this is 100. So just moving things around and using a right-angled triangle, we want to find more information about z. In other words, how fast is z changing. So our relationship is x squared, not x squared, I'm sorry, it's 100 squared plus this entire distance, which is x plus y all squared, equals z squared. And we are told that dx by dt is 35. How fast is boat A moving? How fast is boat B moving is 25. And we want to find out how fast dz is changing. That's our unknown, and we want to do it at 4 p.m. And we start the problem at noon, so it's basically 4 hours later what's happened. So we're going to take the derivative, and the derivative of 100 squared is 0. Here we're going to take the chain rule, so x plus y to the power of 1, and the derivative of the inside is dx by dt plus dy by dt equals 2z dz by dt. We're going to cancel the 2's here just to make our problem a little bit easier. And now we have to substitute in the pieces that we know. Well, we know that dx by dt is 35, and we know dy by dt is 25. Okay, and we want dz by dt, so that's still going to be unknown. So we're looking at the x, y, and z, and we want to know exactly at 4 p.m. So a snapshot at 4 p.m. looks like this. This is still 100, and both of these boats have gone for 4 hours. So if the boat A is going at 35 kilometers an hour times 4 hours, that's 140 kilometers. So x is 140, and the B boat is going for 25 kilometers an hour, so for 4 hours it will cover 100 kilometers. So the y value is 100. So here's my right-angled triangle, and that allows me at this instant in time to figure out what z is. So z squared equals 240 squared plus 100 squared. So z is the square root of 240 squared plus 100 squared, which equals 260. So that means we have the x value is 140, the y value is 100, and the z value is 260. And that leaves one variable, one unknown to solve, which is dz by dt. And if you isolate for dz by dt, your final answer is approximately, I'm going to round this up using a calculator, 55.4